Thanks for coming to high availability meeting today, September 27th. So I was out last week and Reshma hosted for us last week. So thank you very much for doing that, Reshma. I have the notes here about things that we talked about last week, and looks like we had some things that need to be added to the HLDs that I'll take care of. And looks like we talked about, how to do certain things, verify behaviors, things like that. And so we're saying that the HA document review is completed, the one from A&D. And so I hope everyone agrees with that. Were there any other Q&A for them or anything? We could probably bring that up in this call. And then it looked like this week we wanted to talk about this line here, packet flow, and see what happens when there's no ACK from standby. And then overlay ECMP with HA from Gohan. So
sorry, I saw there's an unplanned switchover. We haven't discussed, those detail flows last week.
Switchover. Okay, you want to go over that this week then, Gohan?
Yeah.
Okay. Does everyone agree we could go ahead and talk about that first then this week?
Yeah, just update from my side. I think whatever the review comments that I got, I'm almost done making the changes in the document. I'll probably update and raise a PR with the changes sometime later today or early tomorrow. I'll notify once it's out.
Okay. Yeah, sounds good. Okay, let me just grab this here. Oh. Okay, Gohan. So we want to cover unplanned switchover. And so maybe can we start with the context of the question and what we want to talk about? Gohan?
Oh, can we go over the document again?
Okay. Sanjay, would that be okay with you? Or
yeah,
DJ?
That's fine. Yeah.
Okay, I'm going to stop presenting. Okay. Did you need just a minute, Sanjay?
Yeah, I'm just. Oops.
Got it. Okay.
One second. I didn't present the right. Give me 1 second.
And let me know if you'd like me to present it. Oh, there you go. Okay.
I got it. Yeah.
Okay.
Go on. This is the one you wanted to.
Yeah.
Yeah. So I think here this is the easier flow. So I think the notion here is I'll just quickly go over and then go on. You can put any specific questions and we can talk about. So this is, I think, loss of the heartbeat. Once we detect loss of heartbeat, we update that we have lost peer connectivity has been lost, right, on the old standby side. And then we switch over. There is a jump to becoming the standalone primary, right? Once we move to standalone primary, the peer is gone, so there is no sync happening anywhere, right? We continue forwarding with whatever state we have, the flow state that we have. And the controller has the option of coming and initiating flow reconcile. I think the idea here is once the controller knows that we have the configuration is at the same level where it needs to be, then there is a flow reconcile. When we do the flow reconciliation, we reevaluate the flows based on the current policy, whatever is the policy that is there. And then if there is any changes to be applied, for example, deny flow might have become a permit or the other way around or anything, any other changes that are needed. Those changes are applied and at that point we are done. So that's the high level flow. Right. During this, I think once we switch to primary, I think the key thing is there is no more syncing. There is no this thing because there is no peer available at that point.
How does the SDN controller knows that you know they need to switch to this you know they need to make the standby to be the primary now?
I think it would need to be through some event that we raise. I think the key here is Gohan, because if we immediately right after switchover, if we go and do the if we reconcile the flows, because the configuration may not be up to date, right? Because the controller is pushing configurations independently to each of the nodes. It might be that we might go and disrupt the traffic that is there because we might apply a older config and disrupt traffic and then come back again and then the controller catches up the config and then we this thing. So I think there was a request from Microsoft to leave that control in the controllers this thing so that we don't disrupt traffic, any existing traffic.
Because I think the loss of the heartbeat doesn't really mean the primary is down, right? So it could be, you know, just because the primary could be still there. So in that case, you may have two primary now in the network.
It could be. So we might have two primaries in the network. So what happens is if there is a partition like that, there is a network partition like that. I mean, it may not be a network partition. Let's say, I think you're right, Gon. For example, the case might be a little contrived, but let's say there is in the network, someone put a rule or some ACL or something like that, which blocks only the heartbeat traffic, right? Only or somehow it affects the heartbeat traffic, right? And the heartbeat traffic is not being, received and there's no communication on the heartbeat channel between the two. If that is the case, we would switch over. And I think here the bad case would be where there is partially down, right? In the sense the heartbeat is broken, but the rest of the network is fine. If that is the case, that is still fine. What happens in that case is in that scenario, because currently I think because we are advertising BGP, for example, if you're using BGP, if the control net we are doing with this AS prepend, right? So what would happen is the rest of the network would still send traffic only to the primary, right, and not to the secondary. So what would happen essentially is the secondary would think it is in standalone primary, but receive no traffic. But the active thinks that it is whoever is the admin active thinks that it is standalone primary, and then it receives traffic and continues to forward. Let's say when the connectivity gets restored for the heartbeat. Yeah. When the connectivity gets restored for the heartbeat, they would peer up again, and then it would go back to the same this thing. So it would flush all the flows, and we restart bulk sync and get back to the same procedure again, and the standby would come back up as standby.
How does the controller know that even in the case where heartbeat channel is affected, that there is a switchover?
You mean I think this would need to be via an event that we raised, right, from the switch side. I mean from the
standby.
On the standby side, yeah, we need to raise an event which the controller needs to monitor. I think the key thing is when does the controller see till for the switchover itself, we don't need the controller to know. The only portion where the controller needs to get involved is after the switchover. If you have to do flow reconciliation, right? that is when.
No, but you just mentioned that there is something that Microsoft wanted you to hold back on the config side on the controller. What was that thing?
That is just the flow reconcile. So, and if so, the thing is, so the standby is acting like we were talking, right? So all the flows on the standby are following the policies on the active side, right? So we created the flow on the active before switchover, right? So there was a flow, there was a that hit the active. We looked up the policies, and the policies might be either allow, deny, or it could be some metering policies or something else, right? So we created the flow according to the policies on the active, and we sync the flow as is with the metadata to the standby, and we don't want to reapply the policy on the standby because then we would be out of this thing. So we take the same metadata of whatever is the policy results on the active and sync the flow to the standby. So now when a switchover happens, the flow is according to whatever policies were there on the old primary, right? Whatever was the old primary. Now we continue forwarding the flows. Now there could be potentially it's possible that the configuration state of the policies on the secondary side is a little behind, or is different than what the flows are indicating, right? This thing, because it followed whatever was there on the primary. Now we want to bring it in sync between the policy and whatever is the flow state. So that is triggered by the flow reconcile. When the flow reconcile happens, we walk all the flows, reevaluate the policy, right, and bring it back to. So there might be change in the flow itself. We may need to do some reconciliation, right? There might be a new metering class that is applied to a flow in the active. In the old primary, it was different, but now the configuration on the new on the secondary or the new upper primary says something different, right? So then we'll need to go and apply that policy to the flow. So that is held back.
You're applying the policy because you're thinking that in between the switchover, the policy may have been changed.
Yes, or it might be maybe between switchover, or let's say there is a policy update. When the policy update happens, the controller is not there. It's not an atomic operation, right? To sync the policy to the primary and the secondary at exactly the same time, right? So there might be the primary might have gotten updated, but not the secondary yet, right? It is following behind.
Okay.
It could happen that way. So then within the node, it's not possible to know whether the policy is up to date or not. So we leave that control to the controller to let us know that, okay, policy is now up to date, right? Now we can go and reconcile this flow state. Like, we don't want to be caught up behind. We don't want to be applying an older policy and then disturbing the flow. And then immediately after that, we get the newer policy and then reapply, and then we don't want to do that. So we just want to hold off on reapplying, doing the reconciliation. That's the one that is held back, or that is what is dependent on the controller. But whatever the existing flows that are there and whatever flow state was there, we continue forwarding as soon as the switchover happens.
Yeah, so essentially what you're doing is that you're doing the flow simulation, right? After the switchover?
Correct.
Okay. Okay, good, thanks.
So where are these 2 seconds coming from? Disruption time, 2 seconds. Where, what decide that? I don't see anything in this step mentioning about the 2 seconds. How do we, what's there to guarantee the 2 seconds?
So this would be dependent on us detecting heartbeat loss, right? And anything that we need to the data plane to start forwarding again. Right? So far, we mean the standby is dropping traffic, right? We are not, even if we receive traffic, we will not use the flow state to forward because the state of the data plane is in standby, right? Is in the secondary state. So we have to do, there is some activity that we need to do to start forwarding, right? That is one. And the second component, that is one component, which is software or whatever work on the DP or on the node itself. There is also this thing which is another component for drops, which is the network itself, right? So when this thing switches, if you need to, let's say there is an actual failure on the primary side, for example, BGP or whatever is the network protocol, has to reconverge and start forwarding all the traffic to the secondary side. So this 2 seconds is our goal, Gohan. Right, this is what we want to. I think all our testing, whatever, I mean, so far what we have done is to make sure that we do not exceed that 2 seconds. Right, we are trying to do whatever we can to keep it.
No, I guess that part is the goal, but what are the components that in this system to to help us to reach that goal? That's my question, right? So what are the components that you mentioned is the heartbeat and you mentioned the network. So how do we guarantee the the heartbeat that will meet this 2 seconds? So what is our heartbeat rate currently?
Yes, I think that is bulky. I think it's 150 milliseconds, 200 milliseconds. How much is it bulky?
Current, yeah, with our testing, yeah, we tried with 150 milliseconds. It's more to, yeah, we have to tune it and see what suits, right, based on the actual deployment.
But what is the critical path here, right? So because we lost the heartbeat, and then when do we start advertising and from the loss of the heartbeat to the point where the previous standby is fully functional? So what are the critical paths that we need to do, and what is the time spending on each of those components? Do we have a a breakdown of those timelines that starting from the loss of heartbeat, what are each step that we need to carry out in order to for the new standby to be?
Yeah. So I think from our testing empirically, I think we can break it down, Gohan. We don't have that this thing yet. I think Balki might have something from our testing, but it's not there in this document. But one thing, though, Gohan, what we are trying to do is one optimization or this thing that we take care is on the standby. Consciously, what we have done is we have tried not to advertise only after we detect switchover, because then what happens is we are adding to that. We are adding one more component, right? That the route has to start propagating up, right? So instead of that, what this is what we did with this thing. I think we will talk about it with the ECMP approach too. So the idea here is we don't try to create one more leg, which is that route propagation itself, is to create advertise the route only when we do switchover. Instead of that, even before switchover, we are advertising the route, but with a worse metric, right? So all that happens is so when we lose the route on the active side is when it will switch over to this backup path. So that way we kind of reduce the switchover time, right? So that is one component, which is the network component. Other than this, I think like this thing was saying, like Balki was saying, 150 milliseconds. This is the actual heartbeat detection time itself, right? So there is some detection time. And after we detect, there is some activity that we need to do so that we switch over to switch the state to being standalone so that we can actually start forwarding the traffic. So these are the three components within that successful switchover time.
Okay. I mean, that's much more clear. Can we update the document to include, that critical path analysis?
Sure, we can do that. In this, we can try and add what happens during switchover. What are the pieces that are involved? Sure, come on, we can do.
All right, thanks.
Yeah.
So I saw there was because it was mentioning the metering. So I mean, I just asked a not quite related question. I don't know if it has been discussed. So during the switchover, did we also replicate those metering data from the primary to the backup?
No, go on. It's not replicated. We don't sync the state itself.
Okay, so then those are lost, right? So if they are doing the billings and those data are lost, then how do we get that recovered, or what was the plan?
So I think the plan was I think the controller polls, right? To collect the data. So within that polling interval, I think there is some loss. So it might have polled the primary at whatever frequency, collected the meter data, and then if the switchover happens, and then we start metering on the new primary, right, on the other side. So whatever is the loss within that polling interval, that loss is still there, but the meter class, etc., will remain constant. So if there was a class ID allocated to it in the previous side for a particular class of traffic, then the same class ID will start metering on the other side. But there is that loss within that one polling interval. Whatever was lost is lost. I think that is the plan too.
Okay. Did we explicitly call this in the document?
I don't know, metering, not here, but yeah. So this will apply to a lot of other things also, right, Gohan? Metering, I just brought it up because I thought some policy thing other than just permit deny. But anything that stats or anything that we are collecting, because we are the only thing that we are syncing between the nodes is the flow state. It's not really all the metering state. We are not syncing everything because that would require a lot of bandwidth, right, to do that.
Yeah, can we call out what are the not syncings and what are those expectation for the controller side? Apart from the meter, you mentioned there are other state where syncing and there be implication on those. Can you elaborate?
Sure. I think, or can I add, maybe in somewhere we'll elaborate, we'll say that the only states that we sync, I think it's more of what we sync, right? Everything else is not synced. I'll add that one. I think somewhere we say, I'll make it explicit. I think somewhere we say we are only syncing the flow state. I can add.
I think, one thing, I think what Gohan is probably asking is that what is an expectation from the controller or an outside entity, how often they should poll and then collect that statistic, so that when the switchover happens, you have only lost perhaps, the last sync that you probably missed, right? So if the controller is collecting that thing every second or every 5 seconds or whatever be the case, right? Then essentially, there's only that much of a billing data is lost when the switchover happens, right?
Correct. Yeah, I agree. The only thing is, I think what I was trying to communicate was, so that would be left to the controller, right? On how much is it, how much for each of these features, how much are we ready to lose, right? So that depends on, that will dictate how often we want to this thing, which might be specific to each feature or what the controller, whatever is the expectation SLA with the top, right? That's why that's what I meant to say. That in this document, we cannot recommend how often to collect. It would be something that is up to the controller. But what I can call out is that we are not syncing all the state, right? All the in-memory state from actives to standby. What we are syncing is only the flow information, whatever is mentioned in this document. Would that make sense?
I think probably we can do it for the planned switchover. At least we can protect the statistics, right? For the unplanned, perhaps you can lose it. But for the planned, if you flush it out or send it out to the whatever the entity that may be outside which is collecting it, then at least you can preserve the data.
I mean, if it's I think it's probably not that critical, right? So either plan the switchover or this. So maybe the expectation, if we do the planned switchover, then maybe the controller would do a query on the primary right before the switchover, so you get the latest data, and once you switch over, then you pull the other side. So therefore, even though maybe the controller is putting at a minute interval, but if they do a pulling right before the planned switchover, then they will get at least very accurate data before the switchover, right? So that should be address alleviate some of the concern that we lose some of the metering data during the switchover, because the switchover is pretty fast, right? So on the order of seconds.
Right. Yeah. I think you're right, Juan. I think with planned it might be even quicker, because once we notify the other side, we are kind of message to the other side to switch to planned.
For unplanned, I guess there's it's a little bit hard to know when that happened, because that's unplanned, right? So therefore you might not have the chance to query that before the switchover happened. So then therefore we would set up some expectations. Say if you are querying a minute, then you might lose a minute of metering data during the switchover.
Right. Yeah.
Right, depending on what is your the pulling interval. So we might and I hope that we can call out those specific in the design document, so that the expectation is clear on the controller side, because we're not planning to do the state replication for things other than the the flow data, right? So maybe you can call. So apart from the mirror, you mentioned there are some other state. What are those other state? I'm trying to understand a little bit more about that things, right? So if we know that there are other state that application requires, maybe we can explicitly call out those things and those specific implications. It would be better, right? So apart from metering, do you know other things that we're not replicating?
So there could be other. There's mirror, and these are all the policies that we have. I can't. I think probably like port mirroring, right? If you are doing some span kind of a thing, I think there was some request to be able to do that. And what else? I'm trying to think through all the policies that we have. Yeah, those are the two. Palki, anything else that any other features that we currently implement already, that policies that might not be this thing, that has some in-memory state?
Policy wise, I think whatever policy we do look up, we carry that as metadata and we try to apply that on the other side. Yeah, I mean, like metering, I mean, obviously stats and all, we don't. Yeah, yeah. Hey, hello, can you hear me, Sanjay?
Yeah, we can. Bulk.
Yeah, okay. Yeah, stats and all, we don't obviously sync, and obviously it is not a sync for every packet, right? So we will not be able to, with respect to state, we cannot sync each and every sequence number, ACK number, those things. With respect to policy per se, I think whatever that we do look up in the active side, we try to take that result to the standby as well.
Yeah. So I think it's only things where we have a policy which carries its own independent in-memory state, right? So those are the things I'm trying to look. I think of metering and statistics. I can't think of any other thing. I'll try to comb through all our policies that we have for Sirius, right, and see what is.
So what is the implication of the sequence number and the ACK number? You guys mentioned that part we didn't sync. So what would be the implication for that if we do not sync those those sequence number explicitly?
So you obviously, after the switchover, you need to basically learn from the packet the sequence number, and then you have to go from that. I mean, if you have to do very sophisticated sequence number, ACK number, checks and all. Yeah, those things. After switchover, you have to first basically you have to relax it a little bit, and then you have to go from there.
Would it be that we would lose the packets but not the flow, right?
So so first question, so I remember, what is are we using the sequence number and the, ACK numbers to do the TCP flow tracking in current, Dash pipeline? Are we already doing that, or we're not doing that?
This is John from Excite. I don't think it's in the behavioral model, but we've talked about this, that
A lot.
tracking the sequence number on the SYN, like you can't get into the established state unless the acknowledgements are for the SYNs, and also for closing the connection, tracking the sequence number of the FIN. I mean, if you track the sequence number on every single packet, you can do even more secure type things like TCP window checking. But I don't think we've ever talked about the window checking. We've only talked about it as a way, for example, like you cannot know that the connection is actually closed unless you track the sequence number of the FIN to the final ACK.
So, okay, so if we're doing that and we're not doing the, synchronization between the active and standby for those sequence numbers. So after the switchover, if we receive a FIN packet, then how do we handle it? Because we don't keep track of those sequence numbers. Right? So is there going to be a problem on that, or?
There is still aging.
Yeah, right. So it seems like the connection won't actively be removed like on the final ACK, but that the flow would be removed based on aging. But there's a small window, there's like a small window there that if the switchover happened between the FIN and the ACK for that FIN, then that flow might need to be aged instead of like actively removed.
Yeah, as long as we got the FIN before the switchover, and then the FIN-ACK got missed, then it will take its time to age out. But if the FIN comes after switchover, then it's as is, no change in the behavior.
I mean, there are a bunch of scenarios here, right? During establishment or during the flow in flight, or towards the end when you're trying to close the connection. There are multiple scenarios where you can have this orphan state on in the switchover, right? Are we relying on retransmits here, or are we how do we reconcile the state to be accurate on the standby is not clear to me. Right, there could be orphan connections and we may have to rely on stuff, but an existing in-flight connection may completely be gone if the state machines don't converge.
Yeah, so there are two things, right? So I think during state change there is this thing. There is switchover during state change. I think this is what we're talking about, the aging catching up, right? Other than that, the flow itself, when it is an active flow, I think during the duration of the flow, when we switch over, that is fine. We relearn the sequence number and then continue from there on, right? So there is no loss of any kind. There is no aging, nothing of that kind. I think the only thing is, since we are using the sequence number, like John was mentioning too, only during the state transitions, right? Either when the state during the create or during the termination of the state. So that is when I think the fallback mechanism is aging. Other than that, I think the switchover does not affect. We relearn from the flow and start tracking it from on the standby side. On the switch, newly primary side.
Okay.
Yeah, depending upon the state, the fallback mechanism could be either aging on the, on the receiver side, but there could be a timeout on the sender side where it can basically, if it is expecting it, then it can retransmit something, right?
So if there was a
you have
SYN,
both.
Yeah, sorry, please continue.
Can we call this as also explicitly in the document saying that because we're not syncing those those sequence numbers, then therefore, some will flow if it's state get transition during the switchover, then we have to rely the new primary has to rely on the aging to age out those flows.
Sure, we can add that one.
And since we're talking about aging, can we, I don't remember this document also covering the regular case when everything is in steady state, we have primary and secondary. There is a flow synced to secondary, and then that flow lasts for a long time, and it should have been aged out under normal circumstances, but there is traffic going through primary, so primary won't age it out. So how will secondary handle this?
The aging is always it is driven by the primary, right? So any flows that needs to get aged out gets aged out from the primary, and the secondary does not age out. Other than that, I think there is a very long timer. Maybe Balki can.
So okay, so when if the flow is removed by aging and not by fin, how will secondary know about that?
It's synced from the primary.
Is it specified in the document as well? Because I didn't see it.
Aging, maybe we haven't talked about aging much, I guess, in the document. Yeah.
Yeah, I tried to do a quick search. I didn't find anything. So yeah, this is another thing that's also missing.
Sanjay, last week we talked about the retransmission cases. Maybe you discussed, I was off for a little bit during this meeting. But can we write in the document when the retransmission happens and what are the scenarios it covers?
Sure. I think there is. I think somewhere we had mentioned we rely on this thing retransmission from this thing. We can just talk through quickly if you want. I think when we complete this this whatever we're talking now, we can just go back to the packet flow and see what happens in each leg if there is a drop, right?
Okay.
It gets covered by the retransmission from the client, but we can just go through it if you want.
Okay, and also when there is resimulation happening, right, in the primary that is syncing, do we at that point use the data path sync to sync the entries that have been changed? Because it can happen in background or however the DPU might implement, or will the Sonic gRPC channel get open for the resimulation related sync?
So for I think whenever there is a state change due to resimulation.
Right, state change due to resimulation.
Sorry, I didn't. I was unable to follow that. So I think you're mentioning retransmission, and then there's another resimulation. That is two topics, or
yeah, two separate topics. Retransmission is something that Sanjay will be covering with the example of the packet flow in each state. But the resimulation is a separate topic. Resimulation is when the policies might change on the card by the SDN, and to handle that, there are different ways each DPU might be handling it. And in that case, how do we sync that information of the state change to the HA partner?
Maybe can we explore the topic one by one? Let's can we talk about the true retransmission first, and then have it closed, and then we can talk about the resimulation. Yeah, so
that would be good.
Sure.
So who is going to talk about the retransmission problem here?
Yeah, maybe what we can do is let me come. I think this may be a picture that we can use, right? So this is the flow establishment flow. Maybe what we can do is I'm just thinking we can see in each leg if there is a drop, how does it get addressed, right? That makes sense. So here I think the legs are we have VMA sending to the primary. This is the first leg. Then there is leg 2 where there is a packet that is synced to the secondary back and then going. There are 4 legs in this. So as you can see, right, if any in any leg, if there is a drop, let's say there is a SYN packet, so we can think about TCP and then UDP. So if you take TCP packet, in any of these 4 places, if there is a drop, then the VMB does not receive the SYN, right? So VMA would retransmit the SYN packet, right? Anything during the connection establishment. And that kind of re-triggers, that kind of covers the flow again, right? Wherever there is a loss, that will be this thing. So before 3, if there was, for example, before leg number 3, if there was any drop, then the primary DSC would keep continuing to send the packet to the secondary DSC because it hasn't said that it is synced to the secondary yet, right? So let's say in number 2 or number 3, the packet got dropped. Then any retransmission from VMA, the primary DSC would receive it, send it to the secondary, would keep forwarding it to the secondary to refill the state. But if number 3 leg finishes, right? So there we get an ACK back from the secondary for the flow sync. We know that the flow has been synced to the secondary. After that, let's say the drops are happening in leg number 4. In that case, the packet would come to the primary would forward directly to VMB because we know that it's been synced to the secondary already, right? It would sync to VMB and it would kind of get short circuit. And then hoping that one of the retransmission makes to VMB, then the establishment completes, right? So that would be the sequence. If it is UDP, I think since there is no SYN or there's no this thing, till the ACK comes back, we keep sending it to the secondary. Once the ACK comes back, it's short circuited on the primary.
Sure. What is the ACK for the UDP?
We get a ACK from the DSC. We get this thing that the packet has been the flow has been synced to the secondary. So that is the ACK. In the sense, it's just between the primary and the secondary. We know that the flow is echoed back from the secondary to the primary. That is treated as an ACK.
That's a number 3, right? So
yeah,
the step, the leg number 3.
Correct. Once we get 3, then we know that it's there in the secondary. The flow has been synced to the secondary. And from that point on, the primary does not forward anything to the secondary for flow sync.
That's the same for the TCP, right? So sorry, TCP. Maybe what's the difference between the TCP and UDP? I didn't capture. I saw, before you reach leg number 3, if you receive a retransmission from the VMA, you will always send to the secondary, right? So after reaching the leg 3, then you no longer need to send the packet to the secondary, directly send to the VMB, right? So. And this applies to the both TCP and UDP.
It applies to both. Only in TCP. In TCP, the flow the flow it will not move past SYN, right? The SYN packet in TCP. In UDP, we don't have that SYN. It only changes. The VM can transmit 4 the consecutive packets, UDP packets, and all 4 are lost, right? Could happen that way. In TCP, at least. Because we have the SYN ACK, it gets gated by the SYN if there are drops. Right. What I meant is till 4 happens, right? Till it reaches 4, VMA would not move to a SYN. To the next ACK packet, right? It would keep retransmitting the SYN till 4 happens.
Yeah.
In UDP, we cannot. In UDP, that may not be the case. It may move forward, right? In terms of that's the only difference. But internally, it's about the same. Till 3 happens, we will not. We will always forward the packet what we receive in the data part to the secondary till 3 finishes. Both true for both TCP and UDP. Once 3 is done, it is short circuited. Once leg 3 is complete, it is short circuited on the primary and forwarded to the destination.
But isn't it? It isn't too aggressive when it comes to UDP, depending upon the rate at which you're getting the traffic. Why do you have to send the entire traffic, all of it, till you receive an ACK? Because there is no, the ACK is saying that, okay, yeah, you have received a, could you not short circuit it earlier? And by counting certain number of packets, as opposed to basically sending all the traffic.
Yeah, Manip, the problem is the drop could be in 2 or 3, right? Maybe it is getting to the secondary and getting dropped. So unless we forward, so there are 2 things that control this, right? One is this thing is goal is that we don't want to buffer packets on the primary, right? Because we won't be able to keep up with buffering, right? So we don't want to keep any buffered packets on the primary and send it. We want to not buffer and get the get the packet as it comes and forward as we wanted. We don't stop buffering. That is one goal. The second is the drop could be in either 2 or 3.2. So we want to keep that thing alive by forwarding the whatever packets we receive from the client to the secondary. Yeah, it could be this thing, but as soon as the first few packet comes in, we will. Once 3 comes back in, we will start short circuiting. Right. I think our thing is, if we don't want to do that, if we want to selectively forward, right, then we have to either buffer the packets because it may be getting dropped in between. We'll need to buffer the packets, and it gets a little much more complicated if you have to do that.
So then in that case, you will never have a timer on the ACK, right? If you receive it, but whenever you see the ACK, which is number 3, right?
Right.
There is no timer for the ACK, right? Okay.
Yeah, whenever there is no. Once we receive 3, we know that we have received the ACK and we short circuit. You are meaning that on the flow, is there a timer running per flow to see whether we got the ACK?
Yeah.
Yeah.
There is no time. Looks like there is no need for a timer.
There's no need for a timer. Yeah. Because at the scale of millions of flows, it might be. Yeah.
Okay. Thanks.
Okay, so sorry, so for I just look at the, just a follow-up question. The packet between the DPU, there is a metadata with the policy results. What is that used for? I saw we just send the packet to the send encapsulate and send the original packet to the secondary. What are those metadata with the policy results used for, and do we have those descriptions there? I didn't see any descriptions.
Yeah, so the metadata itself, I think the metadata itself will depend on each implementation go, and that's why we are not called out the what is there in the metadata. We are saying what this thing will be the policy results, right? How we keep the policy results. For example, the policy could be the result of the ACL, or what metering class we decided to attach.
Is that optional? Is that must?
I think whatever is needed by each of the DPU data path to forward, right? That needs to be sent in the metadata. Or the problem will be once it receives on the secondary, right? But if you did not put in the policy results from the primary, we would reevaluate the policies on the secondary, right? For example, let's say there is an ACL. And we want to, if we reevaluate the ACL on the secondary, the states may be different. Here in the primary, we may say permit, but on the secondary, if the policies were not aligned, we may say deny. If that is the case on switchover,
there is reconciliation anyway.
Yeah, but before reconciliation, we'll start dropping traffic. Right, the reconciliation.
Yeah, but it shouldn't, according to your proposal, it shouldn't even get any traffic before reconciliation.
No. I think, sorry, no, that's not this case, Marian. So what's happening is before reconciliation, we are forwarding based on the primary state. The reconciliation only changes the state if there is change to be had, right? But as soon as there is switchover, we are forwarding traffic according to whatever is the state. That is how we are able to keep the drops at a minimum, right? We are continuing. So if the primary had said, let's say in this case, right, if the primary configuration just before switchover, the primary configuration for a particular rule was permit, right? And on the secondary, that the configuration was slightly lagging behind. And if we evaluated the same flow on the secondary, it would be deny. Let's say, right? For example. So when this happens, when the flow got created on the primary, the metadata that gets synced back to the secondary says that it is permit. And in the current state, we would go and install a flow which says permit, right? There is an unplanned switchover, the primary switches over, we get to the secondary becomes the primary and starts forwarding traffic. When we start forwarding traffic, when traffic hits the flow, we still see that it is permit and we forward the traffic, right? We don't drop it, right? So the end clients, VMA and VMB, see no difference in on switchover, right? But when the reconciliation happens, if the controller did a reconciliation at that moment without changing any policies, if it went and initiated the reconciliation, then we would go update the flow to say it's a deny now, right? Then we would start seeing drops. But what we expect is the controller would make sure that we would know that, okay, the secondary is slightly behind on the policies. Before calling reconciliation, it would push the new policies, right? So that it comes in line with whatever was the policy on the primary, and then calls the reconcile. When it calls the reconcile, we see that it is a no op. It was a permit before, even now it's a permit. There is nothing to be reconciled, right? I mean, there's no change in the state. So this way, there is no disruption.
Yeah, I understand what you're saying, but why would the controller, is this really a requirement for controller to wait for the switchover to update the policies? I thought controller tries to keep policies same on both primary and secondary at all times. There might be a delay, but it's in a matter of like seconds. It's not something that lasts for long.
Correct. Yeah. So I think I'm not saying they wait for this thing. It might be delayed, right? It may not be. It's not atomic that it syncs the configuration to the primary and the secondary at the same time. But if we go ahead and do a reconcile, or we apply the secondaries policy immediately, then there are more chances that we will actually disrupt traffic, because the policy configuration on the two is not in sync, right? So we have a flow which was working before switchover, and right after switchover for 3 minutes, it will get dropped, or whatever is the whatever is the time.
Are you assuming like policies just ACL, or is it like everything, like in order to do the transformations, the mappings, the route result, is it like everything to forward that packet, or are you just saying it's the ACL result?
It is mostly the policy results. Anything that is dynamic, like for example, next hop or routing, etc., those are determined locally.
The CAPA mappings
those
are
wait.
SDN, right?
Wait, those are determined locally, so like you can redo like the mapping lookup on the secondary.
Yeah. So if there was for example, if there was a next hop as change, right? Because that we cannot sync from the primary to the secondary, right? Those are different.
So it seems arbitrary, like you're deciding that the ACL is like an important piece of state that you want to move, but maybe like the mapping entries aren't. Like, how do you know that those aren't also delayed and being updated? Like
no, so for the mapping, yeah. So I think Microsoft is asking for mapping also to deal something like the policy. So that is something we are looking into.
Okay.
That is a must.
So, no, that is a must, but the mapping actually, see, when it started, there was no obviously requirement on that side, and also the scale of the mapping is huge. It's humongous, and it's like it's affecting. Yeah. So yeah, that is some requirement that has been raised by Microsoft.
Also, ENI table, VNI table, all that is anything that's coming from SDN, right? That can change. Some things may not change often.
So sure. Okay.
Yeah,
so I echo. I think Christian said time check. So I think this may be a little bit bigger topic. So okay. So how about I think we get quite a few feedbacks on the document, right? So I don't know who I can summarize, but there isn't someone can put and maybe the AMD can take action item to update the document, right? So I think that there are a few things that we found out that the document doesn't have enough details, right? So maybe we can summarize those, and for the metadata policy things, it looks like we need more discussion on that, right? So it's not clear in the document what is needed, whether it's optional, we see argument on that.
Yeah, so
Should we-
Gohan, I'll go ahead and capture, what I've gathered from this last hour and work and send it to Sanjay so that he can have a note of what I heard needs to be updated. And then, we can do that. And then more discussion on metadata policies next time is what you're saying?
Yeah, that's my. Anyone want to continue? I think the
Yeah.
metadata policy might be a bigger topic.
Yeah.
It looks like.
Yeah,
So-
I think I also would like to know that metadata part, because I think I know it's the implementation part, but I think if we know what metadata expectations are, and plus if there is a interoperability is could be achieved, then we can probably see that as well. But at the same
so
time, if we could also have the updates on the GitHub as well, that will be great, for the document.
That's the thing, guys. Like, we can always go into the document and make suggestion in the document to of what you'd like to see expanded as a PR. That's no problem to do that also.
So,
I think the metadata, right? Maybe exactly packet format that is implementation detail. But I'm thinking like at least from the requirement side, right? So there seems some requirement that haven't been captured in this document, like what because I think Sanjay mentioned, someone mentioned there is a Microsoft requirement saying, okay, some policy need to be carried out, but it's not explicitly called out in the document, right? So therefore, there may be some confusions on that front. Maybe I think part of the clarification would be what are those requirements, and right. So those kind of things we need to clarify on the metadata policy.
Well, yeah, I think we can add, probably we can discuss and put what kind of information goes there, not the exact format, because that would depend, but at least we could probably discuss and put what kind of information.
Yeah, because every hardware supplier is going to have something slightly different, right? But if we can level it up, yeah.
Yeah, that sounds good. Thank you.
Okay. So we should probably close out. Oh, go ahead, Sanjay.
Yeah, no, if you can send what you captured. I've captured some feedback here too, but if you can put in what is there.
Of course I will. Yeah, I'm pretty good at taking notes, so I'll send you what I have. And
Christina, for the next time, the resimulation also is a topic that we would like to discuss. I think we talked about it earlier.
Okay, I'll make a note. And I know resimulation has been, on the top of our minds, that we need to figure out how we want to do it. Also, how we want to, how does it get triggered? What are what are the triggers? How do we trigger it? What kind of API? So yeah, I'll mark that down.
Sure.
But I'll go ahead and stop the recording and post it later today. I appreciate everyone's time. And Sanjay, I'll get with you on my notes.
Awesome. Thank you.
Okay, everyone?
Thank you.
Okay, thanks. Y'all have a good day.
Thank you all.
Thanks. Yeah.
Bye-bye.